طيب يعني عزیز ئەم کاتتان باش ئەم بابەتەی ئێستا لە بەردەستماندا بریتێ لە زنجیرەیەک لەوانە و محاضرات lectures لەسەر بابەتی فیزیای ناوک واتە nuclear physics. The subjects under our hand is a series of lectures on introduction to nuclear physics. We will start with chapter 1 titled nuclear structure. Nuclear physics. The branch of physics deals with the structure of the nucleus and the radiation from unstable nuclei. So nuclear physics is the study of the protons and the neutrons at the center of an atom and the interactions that holds them together. It includes the study of the general properties of nucleus, the particles contained in the nucleus, the interaction between these particles, radioactivity, and nuclear reactions, practical applications of nuclear phenomena. These two graphs shows the structure of the atom where the electrons can be seen rotating around the center of the atom in orbits or energy levels, and at the center we have a number of protons and neutrons gathered at the center called nucleus. So the nucleus is composed of two kinds of particles called protons and neutrons. The proton is defined to be a particle that has a positive charge. The number of protons in the nucleus is designated by Z. So the charge on the nucleus is equal to Z multiplied by E, where E is the charge of one particle. The neutron is defined as a particle that has no charge. The number of neutrons in the nucleus is designated by capital N. The protons and neutrons are all called nucleons. The total number of nucleons in the nucleus is A equal to N plus Z. This diagram is a model of the nucleus showing the two types of nucleons. Protons are red colored and neutrons blue colored. In this diagram, protons and neutrons look like little balls stuck together, but an actual nucleus cannot be explained like this, but only by using quantum mechanics. Property of the particles: electrons, symbol is E, charge minus 1.6 multiplied by 10 to minus 19 coulomb, and the mass is 9.11 multiplied by 10 to minus 31 kilogram, while proton P is the same charge as electron but positive, that is to say plus 1.6 multiplied by 10 to minus 19 coulomb, and the mass of the proton is 1.6727 multiplied by 10 to minus 27 kilogram. While neutron N is a neutral particle, so the charge is 0, and the mass of the neutron is 1.675 multiplied by 10 to minus 27 kilograms. Symbol of the elements: X is a chemical symbol for the element, while Z is number of protons in the nucleus, which is called atomic number, and A is a mass number, that's to say is equal to the sum of protons and neutrons. So mass number equal to atomic number plus number of neutrons. Example: describe the nucleus of a lithium atom, which has a mass number of 7 and an atomic number of 3. So A equal to 7, Z equal to 3, so N number of protons will be N equal to A minus Z equal to 7 minus 4 equal to 4. So protons Z equal to 3, neutrons N equal to 4, so lithium 3 by 7 is the description of the lithium nucleus. Isotope. Isotopes are nuclei with the same number of protons, same atomic number, but with different number of neutrons and different value of I. All of the isotopes of one kind of atom have the same chemical property. So the nucleic carbon 6 by 10 6, carbon 611, carbon 612, carbon 613, all its carbon element, and the nucleus of carbon, which contain the same number of protons, 666, while in the first one, number of neutron is 5, in the second 6, and in the first nucleus 610, it means number of neutrons 4, in the second one, number of neutrons 5, and in the third, number of neutrons 6, and in the third, number of neutrons 7. These are all isotopes of carbon. So how many neutrons are in the nucleus of each carbon isotopes? Z equal to 6 for all of these. So N equal to 4, 5, 6, and 7 respectively. Isobar. The nuclei of different elements which have the same number for A are called isobars. This means they must have different value of Z and N. Example, Ne, neon 1023, it means it has 10 protons and 23 minus 10, 13 neutrons. And in the other one, Na sodium 1123, 11 protons, and 23 is the number of total number of proton and neutrons, while in magnesium Mg 1223, 12 protons and 23 the total number of neutrons and protons. So these three different nucleus of elements, all of them has A equal to 23. So these are called isobar. Isotone. The nuclei of different elements with equal value of N are called isotones. So isotones are nucleus or elements which has the same number of neutrons. Example, boron 513, carbon 614, nitrogen 715, oxygen 816. Here in these four nucleus of elements, N equal to 8 for all the same number of neutrons. So these are called isotones. Atomic mass unit, AMU. An atomic mass unit, AMU, is defined to be 1/12 of the mass of carbon-12. Nuclear mass of carbon-12 is 1.660566 multiplied by 10 to minus 27 kilograms. And this is known as 1U, or 1 atomic mass unit. So that's 1U equal to 1.660566 multiplied by 10 to minus 27 kilograms. Mass of proton MP is 1.6727 multiplied by 10 to minus 27 divided by the mass of one carbon-12 atom. So the result will be 1.00728 EU. Mass of the neutron, Mn, will be mass of the neutron divided by mass of the carbon-12, which comes out to be 1.00866 EU. Research is still being done to find out about the composition of nucleons and to formulate a model for the nuclear force that holds the nucleus or the nucleons together. Properties of the nucleus. The mass of the nucleus is given by the sum of mass of protons and the mass of neutrons. So mass of the nucleus is equal to ZMP plus NMN, where MP is the mass of the proton and Mn is the mass of the neutron, and Z number of protons and N number of neutrons. However, experiments show that the mass of the nucleus together is less than the above, given in the above equation. That is to say, mass of the nucleus is less than the total number of mass, the total mass of the protons and neutrons together. The difference between the computed mass in equation 1.1 and the real mass is called the mass defect or defect. So delta M equal to ZMP plus NMN minus capital M, where capital M is the mass of the nucleus altogether, where M is the measured mass of the nucleus. Nuclear radius, Fermi, it is the SI unit of length, and 1 Fermi equal to 1 multiplied by 10 to minus 15 meter. And the symbol is FM. It has been shown that the radius of the nucleus is approximately given by capital equal to R naught A to power 1/3, where R naught is the radius of a nucleon, which is equal to 1.2 multiplied by 10 to minus 15 meter, or 1.2 FM. A is the nucleon number in the nucleus, that's to say atomic number. So the total number of protons and neutrons together called capital A. For an atomic nucleus, M is directly proportional with A, and volume V is also directly proportional with A. This implies that the density of an atomic nucleus is independent of A. So volume is equal to 4/3 multiplied by pi r cubed, and this is directly proportional with A, and R directly proportional with A to the power 1/3. So as an equality, R equal to R naught to multiply by A to the power 1/3, where R naught, as we said before, 1.2 10 to minus 15 meter, and it is equal to 1.2 FM, and FM is Fermi, the SI unit of the measuring of length. Volume of the nucleus. The volume of the nucleus has been considered as a sphere. The nuclear volume V is given by the volume of a sphere. So V equal to 4/3 multiplied by pi r cubed. If you put instead of R, the radius of the nucleus R naught A to the power 1/3. So the result will be 4/3 pi R naught cubed A. And this is, if you put the numerical values of the constants, you will get the value of 9.2 multiplied by 10 to minus 45 multiplied by A. Converting the unit into Fermi, so it will be 9.2 multiplied by A Fermi cubed. Example, find the radius and volume of the nucleus TC 43/107. TC is a nuclear element called technetium. The radius is R equal to R naught multiplied by A to the power 1/3. And if you put the numerical values, we will get 5.7 multiplied by 10 to minus 15 meter. So the volume is V equal to 4/3 pi R cubed. It will be 7.7 multiplied by 10 to minus 43 cubic meter. You can calculate it using converted the units into Fermi also. Density of the nucleus. The density of the nucleus is equal to the mass divided by the volume. Thus the density of the nucleus rho is equal to M divided by volume. So the mass M is atomic number multiplied mass of nucleus. So M equal to A multiplied by M. And then rho, therefore rho equal to A multiplied by M divided by the volume. So M will be equal to M divided by 4/3 pi R naught cubed. Example, calculate the mass density of nuclear matter. Consider a nucleus with one nucleon, A equal to 1. R will be 1.2 multiplied by 10 to minus 15 meter. The density will be mass divided by volume. If we put the numerical values, that will be 2.3 multiplied by 10 to 15 kilogram per cubic meter, a very high value of the density for one nucleon. Thank you very much. I hope that was useful for you, and wish you all success in your mission and in your life.